All right, guys, number 4, y is less than 3x and y is greater than or equal to negative half x minus 1. So which of the graphs below represent this? And somebody in class pointed out that these two are very similar. I will say that you may not be able to see on your side of things. This red positive slope here is solid, and this positive red slope is dashed. This blue line here is solid. This blue line is dashed. We have, if you look up here, where do I want to start? The one where y is less than, this is going to be a dashed line, correct? And that's going to be a positive slope. So let's look here. It could be this one because our positive slope right here is dashed. It could be this one. Our positive slope is a dashed line. It could be this one. So we've eliminated this one. This positive slope is not a dashed line. If we look at the negative slope, y is greater than or equal to this negative slope, the equal sign means this is going to be a solid line. So this is a negative solid line. This is a negative solid line here, and this is a negative solid line here. So we were not able to eliminate anything by looking at that. We can say that our equation with the negative slope has a y. Oh, that was cool. Look what I just learned how to do, you guys. Neat. The negative slope has a y-intercept of, oh, I see. I keep hitting something down here. -1. So this negative slope has a y-intercept of -1. This one does not, so I can eliminate this. This negative slope does too. So now we're down to these two, y, or x and y. Here, these two could be either one of these. So it says that x is less than, or y is less than my positive slope. So here's my positive slope, and y is less than here. It would be here, so that one could be. And y is less than would be here. So this one is not shaded correctly. So yay, we have figured out that graph x is the correct graph for this set of inequalities. Please watch again if you need to, or ask me any questions at school. Again, I apologize if you can't read this very well. Okay, last question for my part, then Mr. Ryder's doing the other ones. The weights of 2 beluga whales and 3 orca whales is 3,600. I'm going to go ahead and just start 2 beluga whales and plus 3 orca whales. Their weights together are 36,000 pounds. It's quite a lot of weight. The weights of 1 beluga and 1 orca, so 1 beluga plus 1 orca equal 13,000. I almost said 100, 13,000 pounds. Okay. So for my kiddos, go ahead and put it in the matrix and figure that out. If you're still having trouble with that, ask me in class. For those of you that want to do it a different way, I think the easiest way to do this would be elimination, because if I multiply this second equation by -2, I'll get these two, I'll get my beluga whales to cancel out. Right, remember you have to multiply it by each term in this equation. So -2 times 1b is -2b. -2 times 1 orca is -1 orca. And I'm just saying the 1 because it really helps me write this problem. As we all know, mathematicians don't have to have the 1 there, but I'm going to keep it there for now. Equals, and -2 times 13,000 is -26,000 1,000. I don't want to jinx myself, but I'm getting a little bit better here, you guys. Now, let's, watch this. I'm going to erase. Let's erase this middle one to make it easier to add them together. I don't have to look at this middle one, because we just changed it to an equivalent equation below. Okay, now let's combine them together. Let's add these two equations together. Positive 2b's and negative 2b's, those cancel. 3 orcas minus 1 orca. Oh, you guys, did you see what I did? I hope you caught this. That should have been 2. I think I even said 2, and then I wrote 1. You were probably already screaming at the television or at your computer or whatever. 3 orcas minus 2 orcas is just 1 orca equals 36,000 minus 26,000 is, obviously, I hope you don't have to use your calculator for that, 10,000. I know Mr. Ryder is probably already yelling at you guys in class if you did this to define your variables. So up here, let's go ahead and do that for him. B is our belugas. Baby beluga. Okay, it's a little bit hard to do. And our O is our orca weight, and this is our orca weight in pounds, and our beluga weight in pounds. So now that I know that one orca is 10,000 pounds, let's go ahead, and you know what, I'm going to rewrite that other equation because that's going to be the easiest one to do, and that was that one beluga and 1 orca, but instead of 1 orca, I'm going to write 10,000. Was equal to 13,000. So if you just subtract 10,000 from each side, oh man, I spoke too soon. I did jinx myself. And that's an equal sign there. Minus 10,000 here. One beluga is 3,000 pounds. So a lot smaller in weight, at least, than the orca, which is 10,000 pounds. If you did this using the matrix, just make sure you know how to read which number stands for which animal in the matrix. And if you have questions about that, ask me. Mr. Ryder is going to be answering the rest of these questions. So in the next video, you should hear Mr. Ryder's voice. And I will see you guys soon.